All right, so 13. So I have something that looks like this. 6, and the way I would express this is that as I write it, 6 times the quantity, since there's no sign there, it's
Mhm.
indicated to be multiplication.
Right.
Times the quantity 2 cubed minus 2 minus 6 times the quantity negative 4 cubed plus 25. And then this will be divided by 4 times the quantity 3 minus a negative 4. All right. So we're going to go a step at a time and work this one out. So order of operations says work inside innermost grouping symbols and evaluate exponents first. Now, when you have a fraction like this, what I'll do is I'm going to work the top and then work the bottom, and doing these separately using order of operations. So what I'm going to basically do is evaluate these exponents first, and that's it.
Okay.
So 2 cubed is 8. So I've got 8 minus 2 minus 6 times the quantity. Now, this is 4 cubed is 64. The negative was not, if this was an even power, I would still have the negative because it's not part of the exponent. So it is, and you can rephrase this opposite of or just negative.
Okay.
But it's negative 64 plus 25. Okay. Now here in the bottom, I'll just write my 4. And bracket. Now, this is what we call double negation. And sometimes it helps when I kind of phrase it opposite. I can just want to take a negative sign and say opposite of. Opposite of negative 4 is positive 4. Or just 2 negatives make a positive. So this would be 3 plus 4. Are we good there?
Because you subtracted a negative, it makes it a
Yes.
positive, so you add
Yep.
them. Okay.
Yep. So the things to put together, one, subtraction, and I'm just writing a general rule here. Subtraction, A minus B, is defined as actually addition of the opposite. So when I look at, where to go? This one right here. I could have written this as negative plus the negative 4. I don't want to make this confusing as well.
That makes sense to me better than this. That actually makes sense to me.
Okay. So, and so anyway, I can rewrite this negative there as 3 plus the opposite of negative 4. And then I just boil this down to what we call our double negation rule.
Right.
Okay. So the upshot is if I have minus and negative, it's addition.
Okay.
So, okay. Now, so from there, I'll go ahead and work inside my parentheses. I'll have 8 minus 2, which is 6. So now it is 6 times 6 minus 6 times. Now, when you are adding what we call addition of signed numbers, one's negatives, one positive. What you can do is think of each number in absolute value. That is positive, except with the exception of 0. 64 and 25. Take the larger minus the smaller. And so 64 minus 25, I'm doing this in my head, that'd be what, 39? And then the sign of the result will be the sign of the larger of the two numbers. That is negative 64 plus 25 is negative 39.
Is that always the case?
Yes. Yeah.
Okay.
So But that will work every single time if you're doing this mentally.
Yeah.
You know, now if you punch it up on your calculator, you'll still get the same result. But in terms of thinking it through mentally, if you have one positive, one negative, make them both positive, take the larger minus the smaller, and then the result will be the sign. The sign of the result will be the sign of the larger of the two. So, okay, so from there, 6 times, oh, at the bottom here, yeah. And I'm going to make my brackets parentheses now. Would have 4 times 7. That is 3 plus 4. Okay, so we'll move this way. So now 6 times 6 is 36. Now, this right here, notice it's going to be what I've got that double negation thing going on again. You would have, you can think of it a couple different, again, plus a -6. It'd be negative times negative, which again is positive, or you just -6 times -39. Either way, this now becomes addition. And that would be what? 54. I think so. 6 times 39. 6 times 39. Oh, 234. And plus 234. On the bottom, I've got 4 times 7. That's what? 28. And all right, so then I can add these two together. That's going to give me what, 270 over 28. And then the only question is, will that reduce? And I know at least 2 is going to go in the top and bottom.
Right.
And but 4 will not. 3 does. 3 would go in the top and bottom. And the reason I know that I can add the digits, that's 9. If I add the top digits up, the 3 digits there, which is divisible by 9, and 2 plus 8, oops, is actually 10, not divisible by 3. So I take that back. So it looks like just 2. And so 270 divided by 2 is 135. And 28 divided by 2 is 14. I will go ahead and check 7, which does not go in the top, so I wouldn't worry about taking it into the bottom. And now, and that is the answer. So,
Okay.
does that help clear up?
Yes.
Okay.
Yes.
All right. Do you have any other questions?
Can you do one for an example that is like XYZ?
Where you're substituting in and then simplifying?
Yeah.
Sure.
Because that's where I get the most confused. For some
Okay.
reason, it's easier for me to do the division, which makes no sense. But the other version,
Gotcha.
on some you move to the left and you move to the right, and then you do whatever you do.
All right. So the very next problem, number 13, you're given the expression 6 plus x times the quantity -6 plus y times the quantity 7 minus z. And you're given x to be -2, y to be 6, and z to be -8. All right, so what we're going to do is substitute these in for the variables here, here, and here. And so this may help it to, once I get them in there, I think you'll be okay. But x is -2. So that is 6 plus -2. I don't need these two parentheses per se, other than I'm just in place of the x, I put parentheses, and inside the parentheses, I put whatever I was substituting in for x. It's just for clarity.
Okay.
Then the next one is -6 plus, and y here is +6, so I just put in the 6. And then this one is going to be 7 minus, and in for z, I put -8. And again, I put the parentheses there just so what was z? It was -8. So notice here I get plus -2. That's the same, or how we define subtraction is addition of the opposite. So that's 6 minus 2.
Okay.
This is -6 plus 6, and that's just straight up going to add to 0. Opposites always add to be 0. And here I get the double negation, where it's 7 plus 8.
Okay.
And I think you're okay once you get to there.
Yeah.
Okay, and so it would now just be 4. And this whole thing, honestly, I can look at this and know it's 0. It's 3 things multiplied together. One of them 0. So the whole thing would multiply to be 0. I mean, just writing it out, it's 4 times 0 times 15. But anything times 0, so 4 times 0 is 0. Anything times 0 is 0.
Okay.
I think you were just having trouble putting the sign numbers in for the variables. That would be my guess.
Probably.
And once you got by that,
There's simple things that confuse me for some reason. It ends up being something I overthink usually.
yeah. Well, anytime you're learning something new, it's easy to overcomplicate it because you don't know what you know. The old saying, "You don't know what you don't know."
Right.
And, so
There was another problem I'm looking for it to ask you about.
in 6-1.
No,
Okay. So, take your time. I'm no hurry.
I'm sorry.
No, there's no hurry at all.
Down, but you know how that goes. Sometimes things just disappear. Basically, it was the same idea except for it said to group everything and
like terms.
yeah. And then like in the middle, it said, for instance, after you group them in like terms, say all the y's on one side and all the fractions on one side or whatever. And in the middle, it said plus, or in the middle, it said minus. My confusion over that is everything on, when you move those things from one side to the next, do you subtract them like you would have if it would have stayed in that order? Because some of them said subtraction because they came from the right side. Or would you just do as it is, like you're saying now, where the negative is basically what you're doing?
Okay.
Does that make any sense at all?
Yes, it does, I think. Here, so we wouldn't necessarily be moving from one side to another. We're not really solving equations. We're just simplifying expressions.
Yeah,
we did look at a few equations when we solved what we call proportions. And I think, so what I think you're talking about is out of 6.3. I'm going to write down I'm grabbing a problem, and then you tell me, yeah, okay, I think that's what I'm talking about.
Okay.
Having to do. So
It is.
the problem looks like this. It just simply says simplify. And you have 10/7 k plus 9/7 minus 2k plus 2/7 plus 2/7 k minus 5.
Yep, that's it.
Okay. All right. So I thought that's what you were getting at. This is actually number 6 on 6.3.
Okay.
Okay. So like terms themselves, like terms have the same variable factors, which means multiplied together. Like in this case, when I read this, it's 2 sevens times k. Same variable factors, and those variable factors are raised to exactly the same powers. So if I don't see a variable factor, I have what's called a constant. Constants are like terms. And then, so when I look at I would have exactly 6 terms here. Terms themselves in an expression are separated by addition or subtraction. You are in one term as long as you are multiplying and or dividing. So when I look at this, I see these 3 terms here are like, and then these 3 terms are like. Now, I combine like terms, if I see variable factors, by simply adding or subtracting what we call their numerical coefficients, or if you want to shorten it, coefficients. But it's the constant factor of the term if there's variable factors. Right. So what I'm going to first do is I am moving the terms around, which I'm allowed to do because addition, subtraction is what we call commutative, or excuse me, addition is commutative. Subtraction is not commutative. I'm allowed to move the terms, and I'll get the same result. So just for clarity's sake, I'm going to rearrange these like this. So I put together the like terms that have the variable factor of k. Then I'm going to group up the constant terms.
And you're just putting the addition symbol in between because they're positive fractions?
Yep.
And
so
this
I
is
see,
-5.
So like right here, or I saw minus 2k, and then I had, so that stayed subtraction.
Okay.
Now, if I had put this term out front here, you actually asked a really good question. It didn't so much come up here, but let's say and there would have been nothing wrong. I could have arranged them this way. So I'm going to make one small change to this. And I'm going to write negative 2k. And then I say plus 10 sevenths k because that term was positive. So it'd be addition. And that's all I've done. I've just swapped these two out. Everything else, and that was just to make a point.
Okay.
If it was subtraction and I had arranged this to be the first term, then it's negative 2k. And so that negative sign, and I think that's what maybe bothers people about using that sign. It has multiple meanings depending on when it's being used and how it's being used. Here it means the number's negative, but here we're talking about an operation.
Right.
Okay. So, and I'm just going to go ... So, and just because we can, I'm going to show you a third meaning of a negative sign, which I have talked a little bit about. But if I have that, it doesn't mean anything about this being negative, and it's not subtraction. Notice it's up I put the negative up in the exponent.
Right.
It means reciprocal of the base, which would be, that means flip it. So take the base and flip it. So when if you are learning about all the exponent rules and really getting into working and simplifying using those exponent rules, you kind of start viewing this as, okay, if I want to make this negative exponent positive, take it to the bottom. And it
automatically makes it positive.
Yes. And so like this would be 1 over x squared.
Gotcha.
Okay. So, and again, yet a third meaning for that symbol. And so that does get confusing when there's multiple meanings depending upon the context. Okay, so now, so back to this problem. I'm now going to combine these 3. But again, what I'll end up doing is I'll write k, and I'm doing the arithmetic of 10 sevenths minus 2 plus 2 sevenths. That is, I'm just adding up those numbers, And so what I would have to do here is this, though. Notice these two have the same denominator. So if I'm doing it by hand,
Mhm.
I need to rewrite this with the denominator of 7, which would be 14 divided by 7 is what? 2. So all I've done is rewrite it into a different form so I have the same denominator. So now if you had your calculator, the TI-30, you could just punch in 10 sevenths minus 2 plus 2 sevenths and hit enter, and then get the answer as a fraction.
Right.
Okay.
Okay.
Since I'm doing it by hand, I'm just that's what and so I'm going to do the same thing here. These two have the same denominator, and then I'm going to write this one with the denominator 7. And what I'm doing is I'm multiplying top and bottom. The bottom's hidden, it's 1, but I'm multiplying top and bottom by 7. What I need to be the LCD, so it would be 35 over 7. And then I can go ahead and combine these. I will have a denominator of 7. 10 minus 14 is negative 4. And negative 4 plus 2 is negative 2. So it's negative 2 sevenths. And then here, we're going to have 9 plus 2 is 11. And 11 minus 35 is negative 24. So now that's 24 sevenths. And so when I write my answer, you could put it in just like this.
Mhm.
I would be apt to just write it as subtraction, minus 24 sevenths. Okay. I'm punching the, make sure I didn't make any arithmetic mistakes. Negative, what was it, 2 sevenths? Oops. All right, so negative 2 sevenths. K. And then minus 24 divided by 7. And hooray, that is the answer. All right, any questions on that one?
So it's negative 24 sevenths, or it's sorry,
Plus,
negative 2
yeah.
7 K plus minus.
Yeah. So
or
I'm
what?
always, yeah, I mean, you could have actually entered the answer in like this,
Okay.
and it would have took it. I always opt for the simplest way to type it. So when I see
Okay.
plus and negative, I'll just write that as subtraction.
Okay. That makes so much more sense to me, because I'm like, where is this coming from? Like, is it because it's on one side or the other? I wasn't sure.
Nope, and so that's it.
Well, that makes it a whole lot more simple in my brain.
Good.
Thank you.
You are welcome. Do you have any other questions? I can help you
Nope.
with?
I think
Okay.
that's all.
All right. Well, you have a good rest of your today. It's kind of warm out there, so
It is.
And I will see you on Wednesday.
All right. Thank you. You have a good day too.
All right, Kevin. Bye.